Applications. So this is where we start writing some problems and then actually solving some problems with linear equations. When you're writing problems, or translating, if you will, you want to try as best you can to just translate straightforward translations. All right? So 5 translates as a 5. Times translates as multiplication. A number translates as a variable, so we'll just call it x. Decreased by translates as a minus. 7 translates as 7. Is translates as equals. And 28 translates as 27. No, just kidding. 28 translates as 28. So if I look at what I just wrote there, I can neaten that up and kind of smush it together a little bit more. 5 times x is just 5x minus 7 equals 28. So there's my equation. All right. Now let's solve it. 5x minus 7 equals 28. We're going to add 7 to both sides. Get 5x equals 35. Divide by 5 on both sides, and we get x equal to 7. That is not our answer, because nowhere in this problem did it say find x. All right? We're looking for a number, so we would just say the number is 7. Speaking of 7, let's take a look at number 7. It says a number, so again, try to write it as you're reading it. A number, x, increased by, plus, so numbers x increased by means plus. 16 is, you guessed it, 16. Is means equals. 14 means 14, all right? But it doesn't just say less, it says 14 less than. So when we have a phrase like less than, it's going to say 14 less than. It's going to take this whole thing right here, and it's going to move it all the way to the end of this side. So it's going to be minus 14. Okay? Now let's read else. What do we have? We have 4, which is a 4, times, which is times, the number, which is x, and then we have that minus 14 come down. So if I kind of look at my whole equation right here, got x plus 16 equals 4 times x minus 14. So if I just kind of smush that together a little bit, we get x plus 16 equals 4x minus 14. Our variable's in 2 different places on both sides, so we got to get rid of one of them. So we're going to subtract x, and we get 16 equals 3x minus 14. So if we kind of bring that up here and run out of room, 16 equals 3x minus 14. We add 14 to both sides. We get 30 equals 3x. Final step is divide by 3 on both sides, and we're going to end up with x being equal to 10. Now again, problem didn't say find x. Okay, we're looking for a number, so we would say the number is 10. Let's take a look at number 8. It says, farmer plants soybeans and corn on his 600 acres of land. He plants 5 times as many acres with soybeans as with corn. How many acres of soybeans and corn are planted? Okay, we could do this 2 different ways. We could do it with equations, and we could do it with a table of values. We've got corn and soybeans. Okay, now we don't know how much corn is planted. All right, so we're just going to say C for corn. We also don't know how many soybeans are planted, so we could say S for soybeans, because that's what we're trying to find. Whatever we're trying to find for the answer, that's typically going to be our variables in an algebraic equation. The problem is, I know that soybeans and corn together have to make up 600 acres. So I know that C plus S has to be 600. We have too many variables in this equation. Remember, we don't like equations that have more than one type of variable. So because I have C's and S's in here, I can't do anything with that equation. However, I do have some information in the problem. It tells us that he plants 5 times as many acres with soybeans as he does with corn. So that means soybeans are equal to 5 times the amount of corn. Well, now that I know that, I could rewrite this equation right here as C for corn plus 5C, because 5C has the same value as S, equals 600. That gives us 6C equal to 600. Divide by 6, C equals 100. So if I come back here, I could say C equals 100. S was equal to 5 times C, which would be 5 times 100, which is 500. So I get 500 soybean, 100 corn. Now, what if we don't want to do equations? What if we don't want to have to sit there and come up with variables and everything like that? Let's just make a table and let's see what happens. So we've got corn, soybeans, and the total. Now we know that corn to soybeans, it's 5 times as much. So if we just start with a random guess, okay, let's say 1 thing of corn. Well, soybeans would be 5 times as much, so that'd be 5. And that would be a total, 1 plus 5, of 6 acres, which is not what we want. We need way more than that. So what if I bump this up into the 2 things of corn? Well, this would be 5 times as much, so that'd be 10 things of soybean. That'd be 12 acres total. Still not enough. What if I tried 3? And then this would be 5 times as much, so 15. That would be 18 acres total. Now what I should notice is every time I increase corn by 1, my total acreage is increasing by 6. All right? Well, I need to be at a point that has 600 total. Well, that'd just be 100 corn, 500 soybeans, which would add up to 600. All right? I could also figure that out by saying 600 over here, it changes by 6 each time, so I could do, well, 600 divided by 6 equals 100. Okay, that's how I know that's going to be 100. And again, this is 5 times as much, so that's 500. And we already know that that's the answer we're going to get from the algebraic version before. All right, number 9. It says a 60-inch pipe must be cut into 3 pieces. The longest piece will be 3 times as long as the shortest piece, and the medium-sized piece will be 5 inches longer than the shortest piece. Find the length of the longest piece of pipe. Okay, this is one, if you recall, we did just using kind of pictures. We drew some pictures of scales. So one scale we know has, and I'm going to cut down on all the pictures I draw just to make it easier here. So on one scale, we know that the large plus the medium plus the small has to balance with the 60-inch pipe, because that's where they're coming from. All right? And that's from this piece of information right here. A 60-inch pipe must be cut in 3 pieces. Now, this, the longest piece will be 3 times as long as the shortest piece. That's another key piece of information. All right? What we could do with that is say that the longest piece is going to balance with 3 times the shortest piece. All right. Then we're also told that the medium-sized piece is 5 inches longer than the shortest piece. So that gives us yet another scale that we can draw. And we could say the medium piece is equal to 5 inches longer than the shortest piece. So now, if I start looking at the scale, here's one that has a number, on the one side. If we look at all these other ones here, variable, 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 variable. This one here is variables and then a number. And it just so happens that of these three different variables, which we can't really do anything with, three variables, I know that the L variable can be replaced with three of the S's. The M, the medium piece, can be replaced with the small piece plus 5. So that means this scale right here, if I redraw it, instead of large, I could do 3S. Instead of medium, I can do S plus 5. And instead of small, I can do, small. I don't have to change that because that's the same variable that I use for everything else. And we know that all together, this scale is going to balance with 60. So if I look, I've got 1, 2, plus 3 more. I've got 5S plus plain 5, and that balances with 60. So if I subtract 5 from each side, 5S equals 55. Divide by 5, and we get S equal to 11. So our shortest piece is 11. Our medium piece, remember we wrote up here, the medium-sized piece is 5 inches longer than the shortest piece. So 5 inches longer than 11 would be 16. And it says the longest piece is 3 times as long as the shortest piece. So the longest piece is going to be 3 times 11, which is 33. I'll just tack my units on there. These were in inches. All right. That's it for that page. Let's start the next page. Okay, number 10. It says the sum of 3 consecutive even integers is 138. So, what you got to be careful about, and I've seen people doing this, is they start and they use 138 as the first one, and they say 138, 140, and 142. Well, let's address something here. Yes, those 3 numbers are 3 consecutive even integers. Do they have a sum of 138 though? No. If I were to add those together, it'd be way bigger than 138. So that is not the answer that we're looking for. Okay, so instead what we want to do is we want to identify and define the things that we're looking for. When we're doing the consecutive integer problems, we want to say, I need 3 of them, so I have the first, the second, and the third. And the first, we always start with just a variable, so we'll just use x, nice and simple. For the second and third consecutive integers, it depends how we're counting. This case, it wants consecutive even integers. Well, remember, even and odd integers go up by 2. So if the first one's x, the second one is going to be x plus 2, the third one's going to be x plus 4. So now I can look here and see, oh, I have a sum that's 138. Well, let's write that equation. The first one plus the second one plus the third one has to equal 138. Well, I've got some like terms here. I don't have any distributive properties, so I could just ignore the parentheses. If I put my like terms together, I get 3x plus 6 equals 138. So if I bring that up here to solve it, 3x plus 6 equals 138. And I subtract 6 off of each side. 3x equals 132. Divide by 3 on each side. And we get that x equals 44. Now if I come back over here, and look at my first, second, and third integer, I know that x is equal to 44. My second integer is 2 more than that, so 46. My third integer, 4 more than that, is 48. So I've got 44, 46, 48. And if I did find the sum and add those together, guess what? It does add up to 138. Right? You should always be able to make sense of your answer. Now, in this particular case, they just want the answer of the smallest integer, so I would just write 44. All right.